Today's section goes with section 1-5 in our book, Scatter Plots and Least Squares Line. Today's learning goal you can read. The first part we will be doing here during the lecture. The second part we will specifically be covering during class using our graphing calculators. So when we talk about lines or lines of best fit, it would come from the situation where you have a series of points, and all those points are not necessarily on a perfect line. If I asked different people to come up and draw what they would consider the line of best fit, we might get somebody who says, well, I like the idea of coming up and drawing a line that swings through the middle. Whoa, that's a little big. Back that off. Swings through the middle of the data. More like this. So it's in between the basic points, the middle of the data points. Or someone else's idea of line of best fit would be maybe take the most extreme points and include those in their line. So down here we might have a line that would include the point and come up and include those extreme points. So some of you might have a line more typical like this one in pink. We could go on and ask several people to come up, and we could have a whole different set of lines listed here. Well, there has to be one line that would represent, as they say, the best fit. And that's what today's section is about. So moving forward, that line of best fit actually has been called three different things throughout mathematical history. Line of best fit is what we're going to refer to it as least squares line, which is a little antiquated, and then the regression line, and that comes from, that's what it is actually called on a graphing calculator. All of the lines will take on the form of y equals mx plus b, which we're used to from Algebra 1, slope-intercept form. So every line that we find will be y equals mx plus b form. Now, when we work with the calculator, there will be something that I now go through and describe for these lines. Obviously, they're not perfect lines, so there has to be this diagnostic tool that says, well, how good a line is it? How well does it fit the data? We're going to have something called an R value, which is the correlation coefficient. For whatever line that our calculator will spit out an equation for, there will be an R value that corresponds to it. And again, the calculator will spit this out. So when we get to class, we'll be showing you. That R value will take on any number between 1 to -1, inclusive. Most of the time you will see decimals from your calculator. The sign of that R value, positive or negative, indicates the direction of the relationship between the variables, meaning the same as the sign of R indicates the same thing as your slope sign. So if it's a positive slope, it'll have a positive R value. If it's a negative slope, it'll have a negative R value. A couple other characteristics dealing with this correlation coefficient. The absolute value of this R value indicates the strength of the linear relationship, so the absolute value of it. When the absolute value of R equals 1 exactly, we call that a perfect linear relationship. You would notice that the points all line up on a perfect straight line. There are no points that are just a little over, a little under, not on the line. They are all exactly on the same line. The closer the absolute value is to 1, is R value's absolute value, the stronger that relationship is. So the R value, absolute value of R, if it's a 0.99, it's very close to 1, a 0.85, fairly strong, we like to call that. Those are words we use to indicate how good a relationship it is. An R factor of 0 or closer to 0 indicates no linear relationship. So if the absolute value of R is a 1, it's a perfect fit. If it's an absolute value of R close to 1, it's a strong fit. If it's an absolute value close to 0, it's a poor fit. Basically, we'd probably say there is no correlation because you can draw so many different lines through the set of points that you would have. So usually we can see a positive correlation, a negative correlation, or no correlation when we plot the points. This R value will tell us something about our data set without even having to plot it. So when we get to class, we're going to do 2 things, and that is show you on your graphing calculator how you go through what is called the least squares line, line of best fit, with a key sequence. And then you should be able to come to class with some questions about this R correlation coefficient if you have it.